Hello viewers, welcome to my channel once again. Today we'll be talking about software engineering, and with this course you are going to understand what software engineering is and why it is important, and also you're going to understand the developmentals of different types of what software systems which may require different software engineering techniques, and you're also going to understand some ethical and professional issues that are important for software engineers. So let's run through this quick very fast. You see, the notion of the software engineering was first proposed in the 1968 at a conference held to discuss what was then called the software crisis. It became clear that individual approaches to, program development did not scale up towards large and complex software systems. So they were unreliable. They even cost more than they expected and were delivered late. Okay. Throughout the 1970s and the 1980s, a variety of new software engineering techniques and methods were developed, such as a structured programming, information hiding, and object-oriented development. Tools and standard notations were developed and are now extensively used. We can't run the modern world without what? A software. National infrastructures and utilities are controlled by computer-based systems, and most electrical products include a computer and a controlling what software. Industries or industrial manufacturing and distribution is completely computerized. As this is a financial system, entertainment, including the music industry, the computer games, and film and also television, is a software intensive. Therefore, we will say that software engineering is essential for the functioning of what? National and international society. Software systems are abstract and what? Intangible. The word over here is intangible, meaning you can't wood it. They are not constrained by the properties of what? Materials, or governed by physical laws or manufacturing processes. This simplifies that software engineering, there are no natural limits to the potential of software. However, because of lack of physical constraint, software systems can quickly become complex and also difficult to understand and expensive to change. There's so many different types of software systems, from simple embedded systems to what? Complex worldwide information system. It is pointless to look for universal notations and methods or techniques for software engineering, because different types of software requires different approaches. Developing an organizational information system is completely different from developing a controller for a scientific instrument. Neither of this system has much more in common with a graphic intensive computer game. All of these applications need software engineering, and they do not need all the same software engineering techniques. There are many reports of software projects going wrong and software failures. There are so many factors, but these are the two factors that cause software failure. We have one is increasing demand, and the second one is lower expectations. So let's talk about the increasing demands. Okay, so with the increasing demands, as new software engineering techniques help us to build larger, more complex systems, the demand change. Systems have to be built and delivered more quickly. Larger and even more complex systems are required. Systems have to have new capabilities that were previously thought to be impossible. Existing software engineering method cannot even cope, and new software engineering techniques have to be developed to meet new demands. That was how far it goes. Let's talk about the lower expectations as well. It is relatively easy to write a computer program without using a software engineering method and techniques. Many companies have drifted into software development as their product and services have evolved. They do not use software engineering methods in their everyday work. Consistently, their software is often more expensive and less reliable than it should be. We need better software engineering education and training to address this problem. Software engineers can be proud of their achievement. Yes, of course, we still have software problem developing, complex software. But software engineering, we could not have explored space. Meaning, if not for software engineering, we couldn't have even deployed, the space. We wouldn't have internet and modern communications or modern telecommunications. All form of travel will be more even dangerous, and it's just expensive. Software engineering has contributed a great deal, and its contribution in the 21st century will even be what greater. Okay, so if this is all we have to say about what software engineering, then let's come to what we term as what professional development for software or professional software development. I think this is going to be easy, right? A lot of people write computer programs, and people in business write spreadsheet programs to simplify their jobs. Scientists and engineers also write programs to process their experimental data, and hobbyists write programs for their own interest and enjoyment. However, the vast majority of the software development in the professional activity where software is developed for specific business purposes, for inclusion in other devices, or as a software product such as information systems, the CAD systems, etc. Let's talk about professional software. What is intended to use for? So it is intended for use by someone apart from developers. It is usually developed by teams and rather individuals. It's maintained and changed throughout its life. Software engineering is intended to support professional, software development life. Software engineering is intended to also support professional development rather than individual programming. It includes techniques that support program, specifications, design, and evolution, none of which are normally relevant for, personal software development. Table 1.1, we're going to talk about it. We summarize more frequently and ask questions in software engineering. So sometimes I always see many people think that software is simply another word for computer program. However, we have that wrong. However, when we are talking about software engineering, software is not just the program themselves, but also an associated documentation and configuration data that is required to make this program operate correctly. Yes, that's a good definition. Don't ever think that software simply means another word for computer program. When you are dealing with software engineering, you are talking about the software program, you are talking about the computer program, and it's associated, configurations or documentations. That is the right statement to use over here. So a professionally developed software system is often more than a single program. The system usually will consist of a number of separate programs and configuration files that are used to set up this program. It may include system documentations, which is going to describe the structure of the system, user documentation, which is going to explain how to use the system, and the website for users to download the recent product information. This is one of the important differences between professional and amateur software development. If you are willing to write a program for yourself, no one else will use it, and you don't have to worry about writing programs, guides, documenting the process, design, etc. Yes, that's true. If that is your own personal thing, you don't need to write all these things. But so far as you're developing it for people to use or on organizations, then you have to do the configurations and also the guidelines for us to be operated very well. Is that okay? So if that is okay, I'll move on. However, if you're writing a software that other people will use and other engineers will change, then you have to provide additional information as well as the code for the program. Yes, so this is a little bit introductions that we can say about what software engineering. If you really like this course, follow us for the next part. Thank you very much.